Hello and welcome to our lesson. I'm sorry I can't be here with you today, but I want you to take some notes on all methods that are discussed here in problem 107. So here's the problem. Multiple strategies. JR's team is trying to find multiple ways to solve 3/4 equals x over 6 from problem 7-106. With your team, analyze each of the strategies that follow. Some of these strategies might be the same as what you came up with in 7-106. However, others may be new. Work to understand each strategy so that you can use it to solve a new problem. Seven 107A, the giant 1 method. Now we've actually been using this quite frequently this year. So I'm going to show my work over here, and this is where you can take your notes from. Okay, so the giant 1 method basically says if I have an equation like 3/4 is equal to x over 6, I just need to find an equivalent form of 1 that allows me to multiply 4 to get 6. And if I multiply 3 by that same number, the numerators, I get x. So 4 goes into 6 1.5 times, so I suppose we could multiply by 1.5 under 1.5. And when you do that, 4 times 1.5 is 6. 3 times 1.5 will be the value of x. So 3 times 1.5 is equal to x. In this case, that's going to give us 4.5 is equal to x. We can conclude then that the answer is 4.5 or 4.5. So x is equal to 4.5. We've been doing this method a lot. You should already know how to do that problem. If we type that into here, 4.5, we get some confirmation. All right, the second method that we need to know about is going to be the undoing division method. Not a great title, but it'll work. So part B, looking at JR's work, Letitia said, I see it differently. We just need to find some number that when divided by 6, you get 3/4. Right? She's talking about the x. When you divide it by 6, it equals 3/4. We can undo the division by multiplying each side of the proportion by 6, like this. Then Letitia shows her work at the right in the sketch. So you can see right here that Letitia is showing that she's multiplying this by 6 and she's multiplying this side by 6. By doing that, she's creating a giant 1 right here, right? So the notes that I'd like you to take start with 3/4 is equal to x over 6. And then we're going to multiply by this 6. So they do it as 6 over 1. Okay, that's fine. The goal of this, which we've talked about in the past, is to make this 6 at 6 an equivalent form of 1, leaving us 1x on the right. So if I do that right here, I get my equivalent form of 1. So this is going to equal 1x on the right, and on the left side, 6 times 3 and 1 times 4 is 18 over 4. If I simplify that, I get 9 over 2 is equal to x. If you want to make it a mixed number, x is going to equal 4.5. Again, same problem, same answer. This is the undoing division method. Now, we've had a lot of practice with this. We're going to go on to another new method right now. Fraction busting. Well, fraction busting, we kind of already did that before too. Let's see what he has to say. Avner asked, but if I multiply both sides by 6, if multiplying both sides by 6 gets rid of the denominator of the x, then can we use the same strategy to get rid of the 4 in the other denominator? Like when we do fraction busters, right? Discuss Avner's question and decide if undoing both denominators using fraction busters is a reasonable strategy. So we talked about this before also, that if we can find a common multiple of 4 and 6, we could use it to multiply to clear this fraction. Now, we've actually done this prior to this. In his example, he's saying, look, I can multiply by the 6 because multiplying by the 6 on both sides will let me make a giant 1 with this 6. If I multiply both sides then by 4, that'll let me make a giant 1 here. And what's left behind is 6 times 3 and x times 4. Now, when we did this before, instead of multiplying by 4 and 6, we actually found the least common multiple, and we multiplied by 12, which is another way to do this problem, and I will show that in just a moment. But Avner's method actually has an interesting outcome that we're going to be able to use later. If he multiplies both sides by 4 and by 6, by both of the denominators, what he gets right here is 6 times 3. And what he gets right here is x times 4. Later on in today's lesson, you're going to see something called the cross product method. And what it says is if you cross multiply any two fractions that are equal, if you cross multiply the numerators with denominators, you get another equivalent statement. So be ready for that one, because that's kind of a cool one. Now, I said I would show this problem a different way, and I'm going to do that in just a moment here. So, if we were to take 3 over 4 equals x over 6 and use our fraction busting method, all we need to do is multiply both sides by the least common multiple of the denominators 4 and 6. So in this case, the least common multiple of 4 and 6 would be 12. That's going to be my fraction buster. So 12 times 3/4 is equal to 12 times x over 6. When we do that, we end up getting a giant 3 right here and a giant 2 right there. 3 times 3, 3 groups of 3 is 9, equals 2 groups of x is 2x. If I then take the 9 divided by 2 and the 2x divided by 2, I've created a giant 1x is equal to 9 over 2. So I can conclude that x is equal to 4.5. So that was the other way to do fraction busting. Similar to what he did. He took 3 over 4 equals x over 6. He multiplied this by 6 and this by 6 to clear the 6. And he multiplied the left by 4 to clear the 4 and the right by 4. And that gave him everything he needed to get 6 times 3 equals 4 times x. You might notice that 18 equals 4x. When he divides by 4, he has 18/4 equal to x, but this needs to be simplified. If you divide both terms by both numerator and denominator by 2, you get 9/2 equal to x, which is the same as we had there. So fraction busting by the least common multiple can get you an answer that does not need to be simplified as much. And if you fraction bust this way, it'll do just as good. All right. Our next method is going to, it's going to be on problem 7-110. This is called the cross product method. And the cross product method basically was invented by fraction busting. So if I take, for example, this problem 10 over 4 equals x over 7, and this is problem 7.110, by the way. If I were to multiply everything by 7 first, to get rid of the 7s, to make the 7s into an equivalent 1, and then by 4, I get a 1 here, a 1 there, and a 7 times 10 equal to an x times 4. Well, if you look at these two ovals right here, these ellipses, 7 times 10 is the first diagonal, and 4 times x is the second diagonal. It's actually called the means extremes property of equality. It says that if you multiply the means and you multiply the extremes, which I'll tell you about later when I get back, they're going to create an equation, another equation. So, a fast way to get to all of this is just to cross multiply. And then you end up down here with 7 times 10, which is 70, is equal to 4x. When you divide by 4, then the answer to that division, which is 35 over 2, is equal to x. Or if you prefer, x equals 17 and a half. To solve their problem on 7.110, 2 over 5 equals 11 over x. If we cross multiply, you get 2x is equal to 55. 5 times 11, 2 times x. When you divide by 2 to make a giant 1x, x is going to be 27 and a half. This is called the cross product or cross multiplying method, and it becomes the favorite of most students once they figure it out. You might also have heard of this as a butterfly method if you've heard of it before. Okay, so now that we've finished talking about the different methods, I'd like you to do in your notebook problem 108, A, B, and C. And I will note that on problem 108A, they ask you specifically to use Letitia's method of undoing division. So go back and look at that method in your notes and try to do it that way. On problem B, they want you to use Abner's method of undoing both denominators. You know, fraction busting. You might need to set up a proportion like you did in 6th grade, you know, where you say x goes with 30 as 12 goes with 15, x is to 30 as 12 is to 15, and you write that proportion and then solve it again in your notebook. When you get to part C, they want you to do the giant 1 strategy that many of you are so good at. You will need to figure out the proportion that's hiding in this question right here. Write the proportion in your notebook, solve it, and you can type your answers into the Desmos and see if you get them right too. That'll be helpful. Work together, help each other, learn the material. And then, after you finish 108, I'd like you to go and also do problem 109, parts A, B, and C. The problems are here. You decide if they're proportional, you set up a proportion or not a proportion. Solve the equations and write the answers in your notebook. After you've finished 109, I'd like you then to read the math notes, because the math notes summarize everything you're supposed to learn today. Have a great day, work hard, and ask questions of the teacher if you need help. First ask them from your group members, then ask from the teacher. Thank you.